Hi, I'm Bob. Thank you for joining me once again for this tutorial on the exercises from the textbook Microeconomics, Theory and Applications with Calculus, the 5th edition. I hope it will deepen your understanding of the Cournot model and help you develop your problem-solving skills. Let's go to exercise 3.10. Using table 14.2 and other information from the chapter show how the deadweight loss varies in the airline market as the number of firms increases from 1 to 3. We address the problem in 3 steps. In the first step, we find the output level in a perfectly competitive case because the deadweight loss calculation is compared to the competitive case. We know the market demand function and the firm's constant marginal cost. If the market is perfectly competitive, the equilibrium occurs at the intersection of the market demand and the market supply. The supply curve is the marginal cost curve in our case. We can obtain the competitive output, 192. If the market is perfectly competitive, the quantity is 192, and the competitive price equals the marginal cost, 147. There is no deadweight loss in the competitive case. In the second step, we find out the deadweight loss in the monopoly case. There's only one firm in the market. From the linear inverse demand function, we can directly write the monopoly firm's marginal revenue function. The first order condition for the firm's profit maximization is marginal revenue equals marginal cost. We can obtain the monopoly quantity, 96, and the monopoly price, 243. Using the data in hand, we can draw the graph to show the deadweight loss. The blue triangle is the deadweight loss, the difference in the social welfare between the competitive and the monopoly cases. It equals 4,608. In the third step, we find the deadweight loss for the oligopoly case with 3 firms. From the market demand function, we can derive from one's residual demand, dr. Firm 1 operates like a monopoly with respect to its residual demand. We write Firm 1's residual revenue function and the residual marginal revenue function. The first order condition, marginal revenue equals marginal cost, leads to Firm 1's best response function. By symmetry, each identical oligopoly firm's output should be the same in the Nash-Cournot equilibrium. We can write the firm's best response function with only one unknown variable, Q star, and solve for Q star. It equals 48. Substituting it into the residual demand gives the Cournot equilibrium price of 195. We then draw the graph to show the oligopoly case. To calculate the deadweight loss triangle, we also need to know the intersection of the residual demand and the marginal cost curves. We can find the deadweight loss of one firm is 384. The total deadweight loss of the 3 firms is 1152. It is much smaller than that in the monopoly case. Let's solve exercise 3.11. It is about how the marginal cost and the number of firms change the Nash-Cournot equilibrium price. In previous exercises, we have derived the Nash-Cournot equilibrium price for a Cournot model with n identical firms who face a linear market demand and have a constant marginal cost. The partial derivative of the price with respect to the number of firms n is negative, meaning that as n decreases, P star increases. The partial derivative of the price with respect to firm's marginal cost m is positive, meaning that as the firm's marginal cost increases, P star increases. Therefore, concerning this question, when the marginal cost rises and the number of firms falls, the Nash-Cournot equilibrium price increases. Let's go to exercise 3.12. Why does differentiating its product allow an oligopoly to charge a higher price? By differentiating its product from those of a rival, an oligopolistic firm can shift its residual demand curve to the right and make it less elastic at the equilibrium. The oligopolistic firm operates like a monopoly with respect to its residual demand. Like any monopoly, the less elastic the demand, the higher it can charge to maximize its profit. The math is as follows. Suppose the oligopolistic firm faces a residual demand dr, which is the total market demand minus the outputs from the other firms. We have the equation that relates the price it sets to its marginal cost and the elasticity of its residual demand curve, epsilon r. The market power measure, the Lerner index, equals the inverse of the elasticity of the residual demand. As the residual demand becomes less elastic, which is our case for the differentiated firm, the firm charges a higher price. Thank you for watching this video and working through the exercises with me today. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.